So, hello. My name is Helena, and I will now do my introduction slide. So, I do cybersecurity and forensics at Edinburgh Napier University. I am currently doing half of my third year in a financial institution doing a placement. I'm not allowed to tell you who they are. LinkedIn, though, if you want to know. I used to be part of the NUSEC committee. NUSEC is the rival to Abertay Hackers over at Napier. You should join. And I also do magic tricks, and I am a TEDx organizer. Very happy to talk about either of those things after the talk. The only reason that I'm doing this talk is because I want to get more Twitter followers than my dad. I'm currently about 450 people off, so if you could please follow me. There. That's me. Please. I really, really need it. Bye. I've got a bet going on. Right, so, a short disclaimer, and I will take my cards now. I am woefully underqualified to give this talk. I have not done machine learning in an academic environment, ever, and I don't think I ever will unless I do a master's, which is possible. I did machine learning for the first time as a project at work. It was given to me, and this talk aims to be the talk that I wish I had seen before I actually started the project, because I found it was a little bit of an uphill struggle, especially at the start. If you have done machine learning at work or university, go away. You're not going to learn anything here. This is very much an introduction. You might see a few Faulty Towers gifs, but that's basically all you're going to learn. So, yeah, I won't feel offended if you do get up and leave. So, So this was a Twitter poll I got. Is anybody that voted in this Twitter poll here? 4 people. Okay, well, I guess so this is your fault. So we're going to do an interactive magic trick. I need a volunteer. Thank you. What's your name?
Przemek.
Przemek. Hi, I'm also Polish.
Oh. This was not planned.
No, we have never met before, even though we met.
We did meet at the Morgan Stanley talk every day.
It's a plan.
But this isn't a planned thing. Bang me out here. We haven't colluded or done any. It doesn't matter. Everybody's going to do the trick anyway. Chest. Right. So what I want you to do is to put your hands out like this in front of you. Brilliant. And now I would like everybody else in the room to do exactly the same as Przemek. If anybody isn't doing it, you can put down your coat. It's fine. It's not going to run away. I'm talking to you. Oh, I'm sorry. You're really injured. Okay, I feel bad now. Damn. Okay, don't do this. Okay, if you're injured, please don't do this. Right, okay, Przemek, copy me. Go like this, and like this, and align them. Okay, and now when I count to 3, what I want you to do is to go down and just clasp. Okay? But only once I count to 3.
Clasp, meaning?
Yeah, exactly, but once I count to 3. Okay? Okay, so 1, 2, 3, and everybody's copying Przemek. Right, and now the magic is going to begin. Abracadabra. Psych! You can't do this. Right, round of applause for Przemek. Right, so on to the boring stuff. Oh,
No,
damn, no, we're good. Okay, so, what is machine learning? Machine learning is a subset of AI. Don't keep trying, I'll teach you later. Machine learning is a subset of AI that builds algorithms that allow computers to learn to perform tasks from data instead of being explicitly programmed to do things. So the reason that I've put these things up is because A, they're pretty funny, in my opinion, but also the most common kind of trend that I've noticed in terms of security people is a lack of understanding about the difference between what an if statement is, or a lot of if statements, and an actual machine learning algorithm. Excuse me. So, the difference is that while if-else statements are very good at dealing with data that doesn't change. Machine learning is very good at acting in stochastic or randomized environments. So it's very good at taking new data and figuring out what to do with it, even if it hasn't seen it before. So let's take an example of a dog, right? If we've got an if-else statement that is trying to see if something is a dog or not, maybe it's going to have a question about how many legs the dog has, right? So if dog has 4 legs, then dog. But what if the dog had a car accident and has only 3 legs? So the if-else statement is going to fail at that point, unless it's a little bit of a smart one and has seen this kind of dog before, and a developer has gone in and changed the algorithm to approach this caveat. But a machine learning algorithm, because of how similar this dog is to other dogs, or because of other features of the dog, like its fur, or, velocity of zoomies, and things like that, thank you for laughing, is going to be able to classify this dog as a dog, even though it doesn't fulfill the exact criteria of a dog that it's seen before. I've lost the clicker. So, one question that I've heard a lot as well is, what is AI? What is machine learning? How do they differ? So, you might not see at the back, so I will do the terrible thing of reading out slides. Artificial intelligence is a program that can sense, reason, act, and adapt, while machine learning is an application of AI. So, one thing that we need to understand when we're talking about machine learning is the difference between deep and shallow learning as well. So, deep learning is a little bit out of scope for this talk today, because we've only got 30 minutes, and I completely don't understand it. But essentially, deep learning is good at figuring out what features to select on its own whenever it's trying to determine, for example, a classification of a certain object, while shallow learning needs experts, like security professionals like all of us, to explain to the algorithm which features of a certain object are going to be important when we're going to try and determine what kind of thing it is. If I was going to use a more accurate representation of machine learning and AI and this whole ecosystem of trying to use and apply this area of knowledge to security, this is what it would look like. But we don't have to worry about that because this is a short talk. So, my friend Gordon, who is somewhere in here, I hope. Oh, hi. On a drunken night out, before I had ever touched machine learning, at an NUSEC social, which is great, he said something along the lines of this, which I will read out for the people at the back. I don't understand unsupervised machine learning. Can't you just use the supervisor that supervises supervised machine learning to supervise the unsupervised machine learning? The answer to that is no. But let me explain a little bit more. So it's kind of the wrong question to ask in the first place, because supervised learning requires training on a large labeled data set. So what you're doing is you are feeding the machine learning algorithm data where it will have some kind of way of verifying at the end if it's making the right choices or not. Now, the issue with supervised learning is that you need to have a labeled data set, and these are actually pretty hard to come by, especially in computer security. There are, I will touch on this a little later as well, but the most popular machine learning data sets for example, detecting malicious network connections are from like 1998. That's pretty old at the moment. So we do have a significant lack of labeled data, which is why a more common use case, well, actually, I don't know the statistics, it might not be more common, but a common use case is unsupervised machine learning, which does not require labeled data. At a higher level, what an unsupervised machine learning algorithm will do is it will look at the similarities and dissimilarities between different data points, and it will group them together based on that. So, if it's got a red cat and a green cat, it might put them separately. But if it's got an orange cat, it might put it nearer to the red cat because it's fairly similar. One thing I should probably mention here is that supervised learning is usually has two categories, one of which is classification and one of them is regression. Classification is trying to determine if something is, for example, red or blue, and regression is trying to predict some kind of continuous or numeric variable. While unsupervised learning is going to be divided usually up into clustering or association. Clustering being looking for inherent groups in the data, so for example, dogs, cats. An association being trying to look for rules, so for example, people that click on X will also do Y. It's really warm in here. Right, I know this looks scary, don't worry. I want to point people to this really good cheat sheet just because if you do ever end up doing machine learning and you're using scikit-learn and Python, you will probably come across this, and this is brilliant, especially if you're starting out. But for most of us, we're like Manuel from Fawlty Towers. But let me go through each little bit of this diagram. So, regression. The classic example of regression you can see here. So if you've got 1,000 houses, or huses, I suppose, in Dundee, thanks, you can plot them on a graph where X is the price and Y is the size. Sorry? Other way around. I'm really good at this stuff. Completely right. But anyway, so you plot the price and the size on a graph, and you put each house that you've got in Dundee that you know about onto the graph. So one is here, one is there, etc., etc. Then what you will do is you will try to use an algorithm to draw a line that will best represent all of this data. Which means that then if you've got a new house that is of a certain size, you can go, okay, well it's there, going up to this line, it is probably going to cost around, well it's very cheap, but like £1,300 apparently. And here I will quickly go into overfitting. So one of the issues that you will encounter if you are going to use this kind of algorithm is that you might overfit the data. What this means is that when you draw this line, you can make it fit the data points that you've got so well, like here, that if you change the data, your line won't be representative of the new data anymore. So, for example, if we put a house here, if you had a new house with a size that was here on the graph, you would see that it's maybe not going to be as representative as one that you would plot on a line that is just right. And then underfitting is the other side of the spectrum, where obviously you're not going to have any meaningful results if your line is just basically drawn wherever. Right, next bit of the lovely Python diagram. So we've got classification. I touched on this briefly before, so I'm going to do this fast. Classification is a supervised learning approach where the computer learns from labeled data and uses this to classify a new observation. So it could be by class, so for example malicious, non-malicious, but it also could also be a number of different classes. Now, the Y classification actually has loads of applications, especially in computer security, not only, but here as well. Is it malware? Is it phishing? Is it malicious? All of these things can be solved using machine learning algorithms. The problem is finding good labeled datasets. Clustering. Now, clustering is really interesting, and the reasons that you do it are actually quite cool. So it's an unsupervised learning method where what you're going to try and do is find meaningful structure or groupings in a set of data. Again, like I said before, it uses the similarity and dissimilarity between objects to put them into certain groups. Now, you use this on data that you usually don't know much about. This is called explorative analysis. So the reason that this is hard is because for most algorithms, firstly, you need to determine how many groups you're going to group it into. And for that, you need to basically look at the data, eyeball it, and have some kind of intuition or use complicated and complex statistical analysis to figure out how many groups you want to create. And the other issue is that it's kind of hard to interpret the data sometimes because humans aren't very good at understanding data that is in multiple dimensions because we can't visualize it and we can't see it. Now, apart from finding groups of things, you can also use clustering for anomaly detection. So if you've got 3 very clear groups like here, but then you've got some little blobs that are outside of one of the groups, you can think, oh, well, maybe that's an anomaly, which is useful in security. The last bit of the graph is dimensionality reduction, which is 10 minutes? Damn, okay, I'm gonna go quick. Which is reducing the number of random variables in a dataset. In a dataset, where you will have a number of relevant features that are going to solve your problem. So, for example, if you've got a email, it will have features such as the length of the actual content of the email, the time it was sent, and let's say the sender domain. And you might think that for phishing, the thing that you want to use to classify it as phishing or not would be the sender domain rather than the time that it was sent, because that could be random. Not going into it in detail, dimensionality reduction is basically trying to figure out which of the features are less important than others and taking them away or making them less impactful on the machine learning model in general. I'm not going to go into this. So, why do we need this? Let's look at this from a kind of enterprise security point of view, because I assume that most people here are going to move into that space at some point in their life. So, we have a lot of data, and we have to protect organizations from threats, and we have to detect them as well. So we use lots of threat intelligence feeds, rule-based IDSs, rules about file downloads, etc. to try and do this. But with a growing number of data, and excuse my use of the term, but the cyber threat landscape ever evolving, and the infamous skill shortage in security, we need our people to be triaging threats that actually exist. And there is a lot of false positives in SOCs, I hear. SOCs isn't security operations centers. Not SOCs. My mum is going to watch this one day and she'll be like, what? So, the issues with this is that... Sorry, I'm going to stay here. It's not easy. There's lots of accessible libraries and toolkits to do machine learning in general, but we still need skilled developers to be able to not only understand security, but also understand how to choose the different features that we're going to use to build our machine learning models. Now, machine learning security use cases are usually divided into 2 different things. One is pattern recognition and one is anomaly detection. It's easy to conflate both of them, but they have slightly different goals. So in pattern recognition, we're trying to detect characteristics in data, and these characteristics can be used later to teach an algorithm to recognize forms of data that are the same or different from those characteristics. While in anomaly detection, you're trying to baseline normal and find a notion of normality that statistically covers most of the data that you have, and then anything that differs from that will be classed as an anomaly. So, this is kind of the most important bit of this talk. So, if you want to learn more about machine learning, it is actually pretty accessible, even though the maths is hard. So, I started off with this course on Pluralsight. Sorry, you have to pay for Pluralsight. There's also loads of really good free ones. This machine learning by Stanford is really good, but you have to do it in like MATLAB or R or something that isn't Python, so I was like, no. But scikit-learn in Python is really good. Even just reading the documentation is really good for looking at applications and use cases, although not necessarily for security. And last but not least, machine learning is difficult, but don't get discouraged. If I can do a little bit of it, you can all definitely do a little bit. I think it's a really valuable and rewarding area to get into, especially as it makes you think about what is actually important in security and how we can make, the output of us as security professionals useful to a business. or a country or whoever you work for. And also, you can really impress your friends and family by saying, oh yeah, I do machine learning. So, that was me. Follow me on Twitter once again. And thank you so much for your attention. Any questions?
You started saying this is what you wish you knew. What of what you already knew proved the most useful?
Good question. So I'm not really allowed to talk in depth about the projects that I did at work. However, the stuff I was working on also required domain expertise in networks and network security. So I think that if I hadn't known that and I hadn't known machine learning, I would have been completely screwed, for lack of a better word. But I think intuition about maths and just kind of an ability. I did maths at school. We did one course in uni, but it was really not great. This is being filmed, isn't it? So I think having a bit of an aptitude for mathematics was also really useful. But apart from that, I think, as with everything, it's just grit and determination. Whenever you're, well, maybe not going to lose your job, but whenever your boss is telling you to do it, you just do it.
Python would also help. No?
Sorry?
Python would also help.
Yes, that is a good point. Programming. I couldn't have done it without, to be honest. Any other questions? Okay. Oh, we got one.
So a big problem with machine learning when you think about GDPR and stuff is that it's really hard to sort of justify the decisions that an algorithm makes.
Mm-hmm.
Could that have any negative implications if you use it for cybersecurity? So for example, if I'm like in the search or in the SOC, and I have this machine learning black box doing its thing, and it's giving me all my nice true positives. What about the false positives or the things it doesn't catch? Do you see a danger in that?
So, I'm going to answer this question twofold as well as I can. So, to the GDPR thing, there is a lot of attention put into processing people's data in general, and GDPR and I'm not an expert by any measure of the word on GDPR, but there is a lot of attention put into things like data masking, so making sure that data is anonymous. And in terms of, I don't know how GDPR works for kind of regulatory compliance for not responding to cyber incidents, but yes, whenever you deploy an algorithm, a machine learning algorithm that you don't really understand onto a box and it's telling you this is true, this is false, you have to be able to justify the decision that you made. And I know that in the financial sector, regulators are incredibly strict, and you'd probably get really screwed if you made the wrong decision at some point. But yeah, I think that's the reason that we employ experts that will own the risk for that kind of thing. Any other questions?
Do you think machine learning will replace traditional means of detection?
So I think it will definitely help. I don't think I'm really qualified to answer if it will replace it completely. I think, machine learning algorithms are already being used in AVs and things like that. That doesn't mean we don't have role-based systems as well. I think at the point that they're better and more effective, then yeah, we'll use them. But I don't think, because of the complexity of implementing these things in the first place, I think, rather than there being a bunch of people that write rules for a SOC, there'll be a bunch of people that write machine learning algorithms for a SOC, and those will have to be tested as well, and, the whole problem's just going to repeat itself. It's just going to be more complex. Any other questions? Oh, I'm out of time. Okay, thank you so much.